Hi there! What I'd like to show you today is how to find the average value and then also find the value of c guaranteed by the mean value theorem for integrals. With our continuous function f of x is equal to 2x squared minus x, and we're on the closed interval from -1 to 3. Now when we do this type of problem, we want to first find the average value of the function. So our f sub, and I'm just going to use this notation of subscripting with the abbreviation for average, AVG, and that, recall, is equal to 1 over b minus a times a definite integral from a to b of f of x dx. And here our f of x is x squared our f of x is 2x squared minus x. Our a is the beginning of the closed interval, -1, and our b is the end of the closed interval, 3. So we have our f sub avg is equal to 1 over 3 minus -1 times a definite integral from -1 to 3 of 2x squared minus x dx. Now this integrand can be integrated term by term, and remember, to evaluate a definite integral we find an antiderivative and then evaluate that antiderivative at the upper limit of integration minus evaluated at the lower limit. So putting that into play, we have our average value of our function is 1 over 4 times, well, the integral of 2x squared is keep your base x, add 1 to the exponent, so 2 plus 1 is 3, and we take our constant factor and divide that by that 3 exponent, and then minus the antiderivative of x is 1/2 x squared. Doing the same process. And then this is evaluated from x equal -1 to x equal 3. Plugging in the upper limit of integration minus the lower limit, we have our 1/4 times 2/3 times 3 cubed minus 1/2 times 3 squared, and then that in parentheses minus open parentheses plugging in the -1. And when you work through the arithmetic of what's in the brackets, you'll get that that's 44/3 in the brackets. Excuse me there. And 1/4 of 44/3, we get our average value of our function over that interval to be 11/3. So that's the first part of the process, the average value. Now we want to find the value of c guaranteed by the mean value theorem. And to do that, we have that our f of c will attain that average value for some, at least one c in the closed interval. So we have f of c is going to be that 11/3 for some value in our interval. Well, f of c tells you exactly how to set up that left-hand side. Go to your function f, take out the x's and put in c's instead. So I have 2c squared minus c is equal to 11/3. Now this is quadratic in c, so this will we'll go ahead and multiply both sides by 3 to remove the fractions and make it just a little bit easier to work with. That gives us 6c squared minus 3c is equal to 11. And then quadratic, we're going to bring everything on one side, set equal to 0. And since this quadratic equation isn't factorable, we'll use the quadratic formula. So c is equal to the opposite of the coefficient in front of the first degree term, so the opposite of -3, then plus or minus the square root of that coefficient squared minus 4 times the coefficient in front of the square term, so 6, times the constant, and remember to take that negative with the 11, so negative 11. And that's all over 2 times that coefficient of the square term. And when we simplify all of that, we get 3 plus or minus the square root of 273, and that's all over 12. Now that gives us two different values. We have c is equal to 3 minus the square root of 273 over 12, and c is equal to 3 plus the square root of 273 over 12. And we want to look at the decimal approximation to only report the values of c that are in the interval. We want to report the answer that's exact, but we have to look at the decimal approximations to see which ones are in the interval. So for the 3 minus the square root of 273 over 12, the decimal approximation is approximately negative 1.12689. And for the c is equal to 3 plus the square root of 273 over 12, that's approximately 1.62689. And then looking at our interval from negative 1 to 3 right here, and seeing which one or both could be, but in this case the negative 1.126, that's not in the interval. But the 1.62689 is. So we will report c is equal to 3 plus the square root of 273 all over 12. So there you have it, our average value of our function and the c value guaranteed by the mean value theorem. Well, thank you for watching today, and I hope you have found this video helpful.